Hi, I'm Lou. I do robotics both professionally and as a hobby. When I first saw the Steamdeck, I knew I had to have one, mostly because I wanted to use it for operating my personal robots, but it also makes a fantastic game system. In July of 2022, I released a video describing how to install ROS natively on the Steam Deck using Conda Forge. That video got a lot of views and a lot of interest, but unfortunately it almost immediately broke. Turns out that there is a bit of a compatibility issue between SteamOS and Ogre, which is the game engine that's used underneath of RViz. I decided to reevaluate this solution. Do we really need to run ROS natively on the Steam Deck in order to do teleoperation? Turns out you don't. And in fact, this new solution actually is much more supportable. In fact, it works on Steam Deck, PinePhone, iPhone, or pretty much any Cyberdeck. A Cyberdeck that targets robots. Is that a RoboDeck? I think that's pretty cool. Anyway, today I'm sharing my new solution. And in this video, I'm going to walk through how to turn it on, how to enable gamepad support, which turns out to be a little bit more complicated than I thought. In the next video, I'll talk about video, which is a lot more complicated than I think it should be. Anyway, on to the show. In this video, I'll talk about the ROS Web Bridge. Now, ROS Web Bridge is something that's been around in the ROS ecosystem for many, many years. In fact, I think the first branch is on Indigo, which is quite old. We'll also talk about how to configure the Steam Deck to use the ROS Bridge, because it's kind of interesting. We'll also install and configure the ROS Bridge and share the teleop web app. So let's talk a little bit about the ROS Web Bridge. It is essentially ROS over WebSockets, where you can use TCP or a custom protocol. It works with both ROS 1 and ROS 2. It's really good for control and monitoring, but not necessarily building your own ROS nodes or algorithms, mostly because it has to round trip through a couple of different subsystems. You can publish and subscribe and use services and actions, which is really awesome. And those are the systems we're going to be using today in order to route control messages to the robot through the Steam Deck. Now, these ROS messages are actually exposed as binary JSON, JSON, or XML, and that means that anything that can talk the JSON, BSON, or XML can talk to a ROS Web Bridge. You can find out more information on the ROS Web Tools website. The ROS Web Bridge is fantastic, but it is just the WebSocket interface to ROS. You need something to talk to it, and there's lots of different projects out there for doing this. I decided to implement a web server that runs on the robot and exposes a web UI that talks to the WebSocket. So that's the teleop web application. This is a ROS node. You install it just like a ROS node into your project, and it exposes a web application. Now, this web application is actually implemented in Babylon.js. Now, here's the ulterior motive for this. I intend to rewrite the VS Code ROS extension URDF editor in Babylon.js. There are two things that I really like about this. One is that it is a WebGL application front end that exposes high-level primitives for 3D graphics, but it also provides a two-dimensional UI. That UI, what I'd like to do in the URDF editor is to enable joint simulation on the 3D graphics, so it was ideal. However, in this context, not only can we implement the UI for the gamepad, but we can also hardware accelerate the rendering of the video. And those are two things that I'm interested in from the Babylon.js framework. It launches just like ROS 2 launch. You can launch it just right next to the ROS Web Bridge. And in fact, it will share some of the features or the launch parameters of the ROS Web Bridge. So let's talk about the end-to-end. First, we have the robot. The robot is actually going to run all of the robot code, including the ROS Bridge and the teleop. It's going to serve up applications that will be running on other hardware, Steam Deck, iPhone, PinePhone, whatever. On the robot, you can have Docker or run this natively. And inside the container, inside of Docker, we'll have a ROS container. In my case, I'm using the Foxy ROS container that's published by Open Robotics. And I inject into the workspace the ROS Web Bridge, the teleop web, teleop twist joy, and a motor node. In my case, I have a Steamdeck or a SparkFun JetBot motor node that talks directly to the hardware controller, but this can be any command velocity converter of your choice. On the teleop hardware, we have a web browser, whatever web browser you want. However, if you want to use Gamepad, there are some restrictions on this, and we'll talk about that in a second. The teleop web application will serve up a HTML that is rendered in the web browser, and this is kind of what the UI looks like right now. You can use the touchscreen to drive it, or you can connect a gamepad. Now, in this case of the Steam Deck, it's automatically connected. We're going to be sending sensor messages from the web application to the ROS web bridge directly over the WebSocket, and it will be translating those from JSON to ROS messages that the teleop twistjoy will interpret and turn into command velocities. So that's the end-to-end. So I did mention that the web browser that's installed, if you want to talk to a gamepad, needs to support it. On the Steam Deck, the gamepad is actually exposed a little different than is really expected, so we're actually going to have to configure it quite a bit in order to get there. One interesting side effect of the gamepad API is that it does require a SSL connection. That's going to be interesting. So first, let's go ahead and set up the Steam Deck so that we can have a web browser that actually respects the gamepad. And then we'll talk about how to configure the application. I'm going to switch over to my web browser on my desktop and learn how to install a web browser that supports gamepad. Now, I do know that the Microsoft Edge web browser does, and I believe Chrome does as well, but Firefox doesn't seem to work. So the default browser that Steam Deck recommends doesn't seem to do this. So I'm going to focus on using the cloud gaming system. Now, if cloud gaming is your thing, awesome. This is a good way to get started. However, we're just going to be using this instruction in order to get to the gamepad from an HTML website. So first, let's go ahead and set up Microsoft Edge using this. So first, switch over to the desktop. We're going to install Microsoft Edge, add it to Steam, and then we're going to have to do this interesting little thing here, which is essentially give Edge permission to access the hardware for the gamepad. Once we do that, we can also optionally set up the launch option so it goes full screen, so all you're seeing is the content of the website and not necessarily the web browser Chrome. So let's go ahead and do that. So I'm going to switch over to Steam Deck, and we're going to reboot this into desktop mode. So go to the Steam menu, click the power button, and switch to desktop. Now that it's open, let's go ahead and go to the Discover, select Internet. We're going to find Edge. And install that. Now that it's installed, close the store. We need to do two more things before we switch back into the Steam game mode. The first thing is we're going to go to Application Launcher, Internet, and then right-click on Edge and select Add to Steam. Now, the reason we're doing this is because we need to actually launch it from the Steam client in order for the gamepad to be recognized by applications, because it's not actually exposed as a gamepad HID device. Okay, so now that it's part of Steam, we need to do one more thing, which is to configure the permissions. Go into System, Console, and now we're going to type the flatpak command. Now I've already done it here, so you can see it's flatpak --user space override. space dash dash file system equals / run udev : ro read only, and then the com Microsoft Edge. Okay. With this, we're actually configuring Edge to be able to access the hardware now. Now let's boot back into gaming mode. So now that we've rebooted back into game mode, I'm going to launch Microsoft Edge and test the gamepad to make sure it works. So go to gamepadtester.com and scroll down so you can see this when it starts. You need to press a button for it to be detected. And there we go. It has detected it as a Microsoft Xbox 360 gamepad. And if you move the controllers, you can see that it works. Now that's step one. We've configured the Steamdeck to be able to talk to our robot. But now we need to configure our robot to be able to serve up the information it needs for the application that we're running on this web browser to talk back. So let's do that. So let's go ahead and configure that robot. First, what do we need to do? We're going to need to install the teleop components. Now, if you're running on a Docker container, we're actually going to inject some commands into the Docker file so that this is done for us. If you're doing it locally, you'll want to apt install the teleop twist and the ROS bridge server. You also want to clone the teleop web and then set up certificates. Both Babylon.js and the Gamepad API require that the application that's running be served over a HTTPS connection. We actually do have to set those up. And then we're going to need to launch both the web socket and the teleop web with those certificates. Now, the web browser is going to complain that this is not a signed solution because we're using self-signed certificates, but it is going to go over HTTPS, which is what's needed. So let's go ahead and set that up. I'm going to switch over to VS Code, which has been configured to connect to my SparkFun JetBot. Now, if you're interested in learning how to do this, I have a whole video series for setting up the SparkFun JetBot for Nav2. I'm simply adding a couple of interesting new ones. First, I'm adding the teleop twist joy and the ROS bridge server to my Docker file. And I've also added the image transport, which we'll need for video in the future. This is done on the host. Now, while we're here, I'm going to create a new terminal, and this is just a regular terminal, and we're going to set up certificates. Now, to do that, I've found that the best and simplest way to do that is to use make cert, which is available on GitHub. Okay, so first I'm going to copy a command and paste it. Now, what this command is doing is it's downloading a release of make cert for ARM64 because we're using the Jetson Nano, and outputting make cert into the bin directory. Okay, so go ahead and sudo. So now that make cert is installed, we actually need to mark it executable and install the root certificates that it's going to use in order to create them. There we go. Finally, we're going to create new certificates. We're actually going to put this in our workspace directory. These are actually going to be installed outside of the container, but available inside of the container. So cd into a certs directory and go ahead and make cert. Now here's the trick. In order for these certificates to work, they need the IP address of the host, not what's running in the container. So I need the IP address of this robot, which is 192.168.1.242. And that will actually create a certificate called localhost +1-key PIM, which is what we're going to configure both the WebSocket and the teleop web host for. I'm going to switch over VS Code to a version that has been connected to my container itself. Okay, so you can actually restart this in a container. It'll rebuild the container and actually connect VS Code to it over SSH, which is pretty neat. As you can see, I have the search directory, and I've already cloned the teleop web. So let's take a look at what's inside of teleop web. First, we have a standard package definition. We have a web root, which contains the UI descriptor, as well as the web interface that we are exposing. Okay, we're using Babylon.js here. We have a render canvas. We have a connection to ROS, and we're actually using the ROS.js lib internally. And we're creating a publisher. And then a Babylon scene, which includes the lights and the dynamic texture, which represents the UI. And then we have the puck and the controllers. But ultimately, we're either going to select the gamepad or the UI for generating commands. And here's where we actually synthesize the message and send it. If we have a gamepad, we'll send it using gamepads. If we don't, we'll look at the UI. If you want to use both, maybe that's supportable, but I haven't added support for that. And then we also have a launch file, one that just launches our web application, and one that launches the bridge server, teleop web, and the joystick teleop. I'm going to open up a ROS terminal. So don't use this terminal. Do Control-Shift-P and run create terminal. First, install dependencies using ROS-dep. Make sure all of the dependencies are installed. And then Control-Shift-B, which detects this as a callcon build, and we're going to run callcon build and build this whole solution. Now I do have quite a few ROS nodes in here, so they're going through the entire process of building. Excellent. So switch over to ROS terminal, so ROS create terminal. And this will automatically source the environment for this workspace. And then I can use the start script. So ROS2 launch teleop web with the teleop web, WebSocket, and the joystick node. The other thing we need to launch is our motor node. So create a new terminal, launch the motor node to make sure that we actually can move this thing once we start generating motor commands. And now we're going to switch over to the Steamdeck. Navigate to HTTPS, and this is our entry point for the website. Now, the first time you visit this, it's going to complain about having an invalid certificate. That's because we are self-signing that certificate, not using something that is in a root chain of trust. So go ahead and accept it, because it's something that we know that is acceptable. Okay, so now I'm going to switch over to the Steamdeck. Press the left joystick, which is the activate command, and drive around. And we have a joystick command for the robot. And the other thing we can do is use the on-screen display for navigating that as well. But remote connected like this, it actually switches the input, so I'm not going to be able to demonstrate that, but it is available from the touchscreen on the Steamdeck. Anyway, thank you very much for watching this video. In this video, I've demonstrated how to set up the Steamdeck for a web browser that can use the gamepad, a teleop web that is surfaced up to the application or to that web browser, and how to connect a gamepad or on-screen UI to your robot via the ROS web bridge. Now, if you want to learn more about this, please visit the roswebtools.org. There's tons of other web solutions on there, as well as some other things we'll be using potentially in other videos. I also demonstrated Babylon.js, which is that WebGL application framework that does both 3D UI as well as 2D UI. If you're interested in the nav2 videos, I have those available, but in this, I've provided a link to the Docker container descriptors for the SparkFun JetBot, as well as the teleop web. Thank you for watching, and I appreciate it. Have a good one.